Hey everybody, I'm Nathaniel and welcome to the first episode of Data Talks. This show is for any aspiring data scientist, anyone that's interested in the facts, because there's so much, fake stuff going around, and anyone that's super just interested in becoming a data scientist, from a Python engineer, data analyst, or anything like that. So we're going to be going over a lot today. I come from a teaching background. I teach over at General Assembly. I do their data science course. And as the final capstone project of the data science course, we do something very similar to this. We'll go look at some data, we'll munge it, we'll visualize it, we'll do some models, and we'll come to some conclusions. So this is very similar to the capstone. For those of you that actually are going to be in this class or are doing this, I can imagine this be helpful. But for those of you that are just going for a data science interview, I can imagine it be helpful. So currently I'm doing AI research as my full-time job, and I'm teaching over General Assembly as the part. Vinod, do you want to introduce yourself too?
Sure. Hey guys, my name is Vinod. I'm a data scientist. Currently work for Coursera. It's an online edtech company. Shameless plug. If you want to learn more about data science, more about machine learning, we have some great courses. You should check out the website. I come from more of an economic and statistics background, so it'll complement Nate's computer science background a little bit there. And I'll hand it off to Rock, who will also introduce himself.
Hi everyone, my name is Rock. I currently lead the operations team at a startup in San Francisco. Coming from a similar background as Vinod and really Nate, more of an economics, finance background. But usually, I do data for fun, and that's how I make decisions. So excited to share some insights and experience with every one of you.
Awesome. Okay, let's kind of get started, dive into the data. So let me just screen share. We're going to be using Collaboratory, which I'll talk about a little bit. And I'll present this to everybody. Okay, can you guys see this?
Yep.
Okay. So, I hope we'll be able to cover all of the bases. We've got a lot of stats knowledge here, a lot of computer science knowledge here, and some, business intelligence insights knowledge. For the people interested in the toolage that we are using, I will post some links down below. But what we have here is called Collaboratory. It's using IPython Notebook that you all sort of know, but it allows us to manipulate these cells as if they're like a Google Doc. It's really cool. I'll link it below. It is currently under development, so bear with us as we might freeze or something like that. But I hope this will go smooth. So right at the top, I'm going to go ahead and import like the most important libraries, at least for data munging and visualization. So NumPy, pandas, and seaborn. I'm also going to be setting this right here, interactive cell, AST, abstract syntax tree, node interactivity. And I'll show you what this does in a little bit. But what this means is I'll be able to visualize more of the stuff that I print out a little bit easier. And the final thing I need to do is set matplotlib inline. This means all those visualizations, those sweet visualizations, will be inline. So, okay, let's just start off. Do one of you guys want to talk about what the data set we have is?
Yeah, sure. So we're interested in looking at, movie ratings, and this is a pretty popular concept. The data that we have for this comes from a website called Cinesift. So what that does is it aggregates, many different rating sites together. You think of like IMDb, Rotten Tomatoes, Metacritic, and it organizes them all into one place. And so they have an API that we scraped for a list of all movies that give us this data in one place.
Yeah. So yeah, we've got a lot of stuff. Awards, box office, cast, combo score, blah blah blah. One of the things that we did beforehand is we went ahead and we looked at this data. One of the things we noticed is down here in row 21. So every 20 rows, we go ahead and we repeat the header row. So we see awards, box office, cast. So having a cast which is cast and awards which is an awards is kind of like a red flag. Our data is messy. This will happen a lot. I imagine this happens to you guys on sort of as you're starting any new project. This will happen on a regular basis. We just have really weird stuff.
Yeah, and that's why, when you first load in your data or first get it into, whatever analysis tool you're using, you always want to look at it, right?
Yeah.
And you just want to kind of see what columns are there, what the rows look like. Are there any like glaring issues that you want to fix right away? Because if we haven't looked at this, we wouldn't have noticed the fact that the column names seem to be repeated every couple of rows.
Yeah, which would have been really bad for analysis. So I'll go ahead and delete those. Super simple fix. We can re-examine the data and see that, hey, looks good. No repeat. We also have a ton of columns. I think we've got 48 columns. What is our question going in here?
Yeah, so I think, when you first analyze data set, you want to think of what's the overall goal, right? And our goal for this was really, we're interested in understanding, do critics rate action movies lower than users, right? And this is kind of like a big overarching question, and we can break it down into, individual steps to make the analysis plan more manageable and kind of keep us on track. Okay. And it also allows us to, rigorously investigate the question. So yeah. First, we're thinking about, we want to examine the data, define the columns, create necessary variables. And this is really about limiting the scope of the data set to the pieces that we actually need and making sure that everything there is okay. And so we'll clean and fix anything that we need to do. And then we'll get into the analysis part. We'll do some plots, some more, statistical analysis to actually try and answer the question.
Awesome. Okay. So is this always a good practice to write down this exploratory plan before we start, or should we do it as more like an ad hoc fashion?
Yeah, I would say generally your data analysis plan kind of follows a schematic that looks like this. First you always want to figure out what your overarching question or goal is, and then examine the data and kind of scope it down to the pieces that are useful for answering that question.
Awesome.
Then you want to, make sure you have the right data types, the right columns. There's no glaring issues with any of the columns, because that'll create issues when you go down and try to do your analysis. Then you always want to visualize it first. You want to see what things look like, get a better intuition for the data, see if you can actually answer your question just using basic plots. Yeah. And then you want to get into more of the in-depth analysis to really understand what the drivers are and whether this thing is, statistically significant or not.
Awesome. Brock, do you find that pretty similar for the stuff that you're doing too?
Yeah, in general, you might be wondering, why do we have to do a lot of visualization, or we check the data, again. As Vinod would usually say, that, part of the data science is really to do the same thing multiple times to check if what you're doing makes sense, what you're doing is right, and in general, I would say let's say a large part, 80% of data scientist's job is really to clean data, visualize, explore, see what's going on, and 20% is maybe do a Ttest and see to answer the questions that you actually have.
Yep. I tell my students this all the time. A lot of it is data munging. A lot of it is just doing simple visualizations. So we decided, I'm not sure if we want to go into this too much, but we decided that some things that would be useful for our question, whether critics rate action movies differently than users, would be title, genre, right? Whether it's an action movie, a critic rating from Rotten Tomatoes, that's RT, a user rating, and as well the year. We'll talk about the year a little bit later. I don't know if you guys want to talk about that at all, why we made that decision to choose these columns out of plots that we have.
A quick thing that we can mention is on the Rotten Tomato, there are sort of two kinds of ratings. One is just the aggregate rating for both critics and users, and another one is RT critic meter or RT user meter.
Yes.
From our understanding, the meter represents the percentage of positive or fresh reviews. Which it is compared to the rating itself, loses out the variance because I don't know, like a 7 is the same as a 9 because they're both positive, they're both fresh, and they count as the same in the meter column. So that's why we choose to use rating instead of meter.
Yeah, if you, I guess we should. If we actually did visualize this, and we can do this later on if we think this is interesting, you'd see the distributions are super weird. You've got like a very long right tail in the meter. It doesn't. So we chose to do something that looks a little bit more normal, something that's a little bit more centered, a little less skewness to work with. Okay.
And frankly, something that's a little bit more intuitive in terms of how people think about ratings, right? You know,
Exactly.
usually rate things on like a 5 or 10 point scale, and you have an implicit understanding that a 7 is fundamentally different than a 9, right?
Mm-hmm.
And using the critic rating and user rating will allow us to capture those differences.
Okay. So we're almost done. We've narrowed our data set down to a couple of rows. We've cleaned any glaring sort of data problems. We've got a couple things left to do. One, you always want to check this out. You want to check the number of null rows. So you can look at the head now. It looks very clean. But we notice that the count of number of rows, so 4966, so around 5,000, is less than the total length, so 5,717. So this is a quick way to sort of test, hey, do we have null rows? We do. So I'll go ahead and drop those. Do you guys want to talk about what else we could have done other than dropping them, or we can also just move faster? It's up to you.
Yeah, so I mean, another option other than dropping them is to try and do some, implicit filling in of missing data.
Mm-hmm.
And these are things, there's a lot of like algorithms out there that will help you replace missing values using like the mean of the other cases and stuff. But a lot of these algorithms require assumptions on how the data is missing, right?
Mm-hmm.
And if you don't have a good sense of how the data is missing, whether it's missing at random or there's some, pattern to it, then it's best case is just to drop it and sort of acknowledge that you dropped data in your analysis.
Yeah. And as this is scraped data, we don't have the best intuition as to how this was gotten. Okay. We can also include the scrape script in this too, so I'll definitely link that as well. The final thing I'm sort of visualizing here, this is something that trips up a lot of people that are new to using Python for data analytics, is that this looks fine, right? We've got we've got Godzilla, drama as genres. We've got user ratings that look normal, like 3.3. That looks like a normal user rating. But actually, all of these things happen to be strings. So these numbers, right? These are all strings, which is really bad. So right here, title, genre, RT critic rating, and you can tell it's just a non-null object. So we need to go through and fix this. So I'm going to do this very shortly down here. Change the column types to float. And we'll notice the describe now gives us so much more information, right? We get standard deviation of the critic ratings. We get min, max, blah, blah, blah. Okay. This also gives us some intuition here. We see like the max is 9.5 on the critic rating, and the max of the user rating is 4.7. So these are probably on different scales. So let's check this out. Let's sort of make sure that they are, and these are on different scales. So we'll probably need to fix that in a little bit. That being said, I guess, do you want to talk about Boxplots at all, or is this I can also just link some stuff in the video as well?
Yeah, I mean, I think Boxplots, they may seem like a basic plot, but they're actually one of the most useful kinds of plots you can make, because they give you a sense of kind of the distribution by looking at where the quantiles are. Yeah. And then you can also get a sense of like the central measure of tendency, right, the average, by using the median. And it makes it really easy to compare variables across different categories, right? So we want to compare critic to user ratings on the same plot and compare their distributions. Well, it's really simple to just do a box plot to get a really quick sense of what the two look like in comparison, and it shows right away that they're on different scales.
Yeah, it is quite nice. It gives you a really quick view of what the distribution looks like. So let's go ahead and multiply this by 2. I guess there are some problems. I know, Rock, you had said some things about variance could be slightly different, just by doing the naive thing of multiplying the RT user rating by 2. Should we talk about that, or is this?
No, well, so the reason we're doing the doubling, the rescaling, or modification here is, as we see in the previous graph, user rating and critic ratings are on different scale, and obviously, and a simple way to do is to multiply the user rating so that they are on the same scale.
Yeah.
Here it's kind of fine because we only care about the mean. Test the difference between the mean. as you can imagine, the variance is going to change. It's going to be different because if you double something, the variance should be squared of that.
Right.
Yeah.
Yeah. I mean, yeah. It's some of these times you just need to make these sorts of assumptions and sort of say it's the best you can do. I think for what we did, it's pretty good. We go ahead and we make. We're like, okay, so we've gotten a good measure of user rating. Let's go to good measure of action. We've got two options, I think. One is whether the movie is labeled action in the genre, so it could be a drama action or a thriller action. And another one could be if the movie is only an action movie. And there just doesn't seem to be enough examples of only action movies. So we'll just go ahead and do the first one. If the genre contains action, we'll call it an action movie. And I think this is kind of like, yeah, here we are. I think our data is pretty clean. Yep. So we've got pretty good measures of these things and what they're doing. We've got an is action column, which is super useful. All of the things that should be floats are floats. All the things that should be strings are strings. So at this point, I think we're just going to be doing some visualizations. And mostly for my enjoyment. I love visualizing this data. So you guys have noticed I've been using a ton of pandas prior to this. The thing I love to visualize statistical things is called seaborn. I've done some tutorials for those, so I'll also include them below. But you can notice the seaborn boxplots, they look really nice. They do all of the stuff for you. So they'll show they'll make the whiskers based on interquartile ranges, and you can change those and the medians, and it's all really nice. So what are we looking at here?
Let's think first, so what we did was we
Sure.
identified the question, which was to understand, do critics rate action movies lower than users, right? We had our question, we did our data cleaning, and so now we're getting into the exploratory analysis phase. We're really just doing some basic visualizations to understand this question.
Awesome.
Right? And so, one of the first questions you could have that's relevant to what we're trying to answer is, do critics and users rate action movies differently, right? So we can do simple box plots to compare the distribution of ratings for non-action movies and for action movies, and that's precisely the two box plots that we have here, where the first one is the critic rating and the second one is the user rating.
Okay. They visually look a little different. I'm not sure if I can conclusively say anything.
Yeah, I mean, I would say the distributions look pretty similar. Generally, right, for non-action and action, but if you look at the difference between the medians for critic and the difference between the medians for user, it seems like the difference for critics is larger. And it's pretty noticeably larger, right? You can see it pretty easily in the plot.
Makes sense. So down here, I wanted to just show some cool visualizations off, even though I think these guys aren't a big fan. But these are Violinplots. They're somewhat similar to Boxplots. If you look right in the center, they've got a little Boxplot in them. So that little black thing. So it's got the whiskers, which are the tails. It's got the median, which is the white dot, and it has the 25 and the 75th quartile, which are sort of the edges of this black dot. And then it also shows you a little KD, a little kernel density estimation going on the sides. I'm not sure. It certainly does tell me that the distributions of users and critics do seem different. Critics seem to have a long right tail. And this might be useful later on. If you guys want to speak about Violinplots and how much you've used them in the past, you may.
Yeah, I would say generally people end up just using Boxplots, but it's they're very similar at the end of the day. I mean, Violinplots maybe give you a little bit more information about the distribution and what it looks like, but you can get 90% of the same information with just a Boxplot.
Yeah. Okay, so we go ahead and we do a Pairplot here. This is to visualize. So there's two really nice ways to do this in Python. One of the things I've not sort of shown here, but I can easily pull up. One is a Pairplot. And so what we've got for our Pairplot is in the top left and bottom right corner, so along the diagonals, we'll show the actual distributions of the data. And then along the off diagonals, we will show scatter plots. So how these distributions vary with each other. I don't know. Was this useful to do? Is this too much?
I mean, you can kind of, never look at your data enough in a sense, right? So just doing more visualizations always helps you, right? Like in the Pairplot, we can kind of see that, for action movies, there seems to be slightly more correlation than for non-action movies in terms of critic and user ratings.
Mm-hmm.
That's kind of an interesting fact. If you, look at the Boxplots up above, we can sort of see that there's some evidence for the question we're trying to answer, which is, do critics rate action movies a little bit harsher than user ratings, right? Because the gap between median critic ratings for non-action action movies seems larger than the corresponding gap for user ratings, right? So that kind of points towards the thing we're looking for.
Right. Did you look at? So did you look up this? So this hypothesis, I guess, is Vinod's hypothesis. Did you look at any data before you made the hypothesis, or was this something you just had a gut feeling for?
No, it's just something that seemed pretty reasonable, right? Like action movies are probably not the most, detailed novel ideas for movies most of the time. They're pretty kind of standard things, but they're kind of very entertaining.
Yes.
So if you imagine critics look for movies that are novel or like unique or really detailed or in depth about something, then they're probably not going to like action movies, whereas users who pay for movies for enjoyment might like them more.
Although this could change actually through time.
Yeah.
And in fact, this is back from the future. We looked at the the data, the difference through time later on, and it actually flips. So more on that.
Yeah. We should try to speak in movie titles. Is the goal, right? Just have these references go on. So I mean, we've done a ton of visualizations, probably a little bit more than you might naturally do for a question this simple. But I think we're sort of to the point where we actually want to test our hypothesis. And so we're starting off with a simple t-test. So do either one of you want to explain what we're doing here, why we set equal var equal to false, why we're doing a t-test in the first place? What does it mean?
Yeah, so I mean, the basic thing we're going to be looking at here is, are average ratings for critics and users different in the first place, right? Because this is kind of the most basic form of the question, that if there's a difference, or if critics rate action movies harsher than users do, right, then the average rating for critics and users should differ on the whole. And since we kind of have three different groupings of movies here, we have movies overall, we have non-action movies and action movies, we want to do a t-test for each individual group, just to kind of understand, is there a difference overall? Is there a difference for one specific group in the other or not? That's kind of like why we did the overall testing infrastructure here.
So I know, Rock, you had some qualms about us doing so many tests, right? Do you want to explain why we might be worried if we were doing a lot of tests all at the same time? Yeah. So
if for each of the tests, there's a p-value, right?
Yes.
And so if we, for example, set the threshold of rejecting null hypothesis at, let's say, alpha equal to 5%, and if we just do 100 independent tests, then we can expect 5 errors.
Yes.
And so if we do a lot of tests without adjusting the threshold, then the family-wide error is not going to be different. It's going to be different from the individual threshold that we are trying to set for individual tests. There are certain adjustments that we can do. A simple one would be Bonferroni adjustments, but tend to be pretty harsh. There are other things we can do as well. We'll not go into the details here.
Yeah, we did have a discussion about this, whether we should do this sort of starting off. I think that you'll see later on the p-values that we've gotten, and I think, Vinod, you can speak to this more. We decided that for this type of test that we were doing, it wasn't going to be super necessary. We didn't do anything too shaky. Do you want to speak to this a little more?
Yeah, sure. So we know after we run the test, you'll see what the p-values look like, and the p-values are sufficiently small that even under any reasonable correction, the results won't really change, right? So, we can say pretty confidently that these things are different from one another, even with the fact that we're doing multiple testing here.
Yeah. Yeah, that's exactly true. The p-values are microscopic. I guess just to give you reference on these, you can read them here. We did, again, just as Vinod was saying, we tested 3 groups. We tested the overall movies up top. P-value says we're significant difference. Excuse me. We tested the p-values down here. And it also says, hey, we're a significant difference. And then we tested the p-values down here, whereas these are action movies. So is the action movies from critics to users significant? The significant difference. And are the non-action movies rated by critics and users different? And yes, a significant difference. I guess one thing to be said here is we're looking at the means of these sorts of things. I guess why did we use equal var equal to false?
Yeah, so this gets a little bit into the technicalities of a t-test, right? But there's sort of 2 ways to run a 2-sample t-test. One is to assume that these things come from the same population with the same variance, and the other one is to assume that they come from kind of like different populations with different variances but equal means.
Yeah.
And the fact that we started off with the critic and user ratings being on different scales and then had to multiply the user rating by 2 to get it on the same scale as the critic rating, it seems pretty reasonable to just believe that these variances of these things were actually different, right? So it's a little bit of a more realistic test and a little bit more of a robust test. So we're just sort of being more careful in our analysis here.
Okay.
And I think generally, if you assume equal variance, you get more power.
Yeah.
But it's generally better, unless you have a strong prior belief that they actually would have the same variance, to assume that they would be different.
Yeah. So we're going to go into, so yes, they certainly are different, but does action movies make them more different is an excellent question. I think both Rock and I had talked about this beforehand, and I think both of us were thinking about jumping directly into doing the regression testing right at first. And Vinod had suggested that we go ahead and do the t-test first. Do you have any sort of advice for people in terms of, should we just jump into the exact question? Should we have done these t-tests first? Yeah,
I'm always a fan of starting off with the kind of simplest mode of analysis possible.
Yes.
Right. If we had done the t-test and we had seen that, overall, in the first t-test we ran that tested for all movies, there wasn't a difference. And then in the t-test where we did it for non-action movies, there wasn't a difference. But then with the t-test for action movies specifically, that there was a difference, right? Then we kind of have evidence right away that, oh, hey, look, even the most simplest thing says that critics and users seem to rate action movies differently relative to non-action movies, right?
Yeah.
It just gives you a nice kind of feel for what's going on and a really quick way to do it. I didn't have to think about, how do I want to set up my regression model? What do I want my response to be? What do I want my independent variables to be? It was just really a nice, easy, quick test.
Yeah. Okay, so we're getting into the sort of more fun stuff. We're going to go ahead and set up a simple regression model. This is going to be using statsmodels. For anyone that is using Python or anyone that is using R and wants to switch to Python, you'll find this very friendly. It's an excellent module package in Python for doing most statistical analysis. For doing machine learning analysis, people will also use scikit-learn. And sometimes people will use SciPy. SciPy, as we've seen up here, provides like basic stuff like this t-test, but it doesn't package them really nicely. We've got to extract the p-value. It does not give us a confidence interval instead. Statsmodels really provides it all out of the box. So let me just explain this for 1 second. We go ahead and we make a diff. So what we want to see is there a difference between the user rating mod? So this is the multiplied by 2, and the critic rating. So we calculate their difference, and we want it to do a regression based on if there is that difference, or I guess in this case our the dependent variable is going to be that difference, and our sort of independent variable is going to be is action. So this Boolean feature. We add in an intercept by saying 1. Now you can do statsmodels regression in multiple ways. The way that I like to do it best is this linear model.ols.from formula, just so I can specify this formula using this very simple R-like, this is technically using Patsy formula here, and it gives me a good visual representation of what it is. Again, I've done some tutorial videos on that. I might link them down below. But enough, let's get to the results. I know you guys are waiting. Okay, we specify our model, we fit our model, and then we go ahead and print out the summary. And we've got a lot of stuff here. Oh God. Rock, do you want to sort of take us away with beginning, sort of what are we looking for in this?
Yeah, I mean, the first thing usually I look at is the p-value, or the t, for our independent variable, which is action. And so here the t is 13.5, or it's clearly shows it's a significant factor.
Yeah.
And the next thing I would look at is the R-square to see just how well this model fits, and it's about 3%, 3.6. It's not the best model we can have, but at least we can tell from this output that is action is a significant factor determining the difference between critic and user ratings.
Yeah, so we can kind of take a step back and think about, we built this regression model. What was the point of the regression model, and what is it trying to say, right? And what we're doing here is we're asking, if we model the difference between users and critics as a function of an intercept and an is-action dummy variable, what we're specifically wondering is, is there a difference between users and critics, and is that difference greater or smaller for action movies specifically, right? And so if we specifically put in the is-action dummy and we see that is-action is significant, then one, that tells us the difference changes when we focus on action movies in a significant manner, and two, the coefficient, whether it's positive or negative, tells us the direction of that change.
Yeah.
And so because we have a significant coefficient on is-action, and it's about 0.5, that says that the difference between users and critics increases by about half a rating point when we talk about action movies relative to non-action movies.
I guess this would also be showing that difference is towards the critics making lower scores and users making higher scores for action movies.
Yeah, because the coefficient's positive, right? So that kind of confirms a little bit of our initial hypothesis that users might rate action movies a little bit more friendlier than critics do.
Okay. Do you want to just talk about a little bit of what all this extra gobbledygook is here, and when we, just high level, when we might use this and why we're not going to be focusing on this?
Yeah, so a lot of this other detail here gets at things like, skew and kurtosis, so like higher moments of the distribution of residuals and kind of like what the residuals look like. And that's also what the Durbin-Watson and Jarque-Barra statistics do. The Durbin-Watson and JB statistics are specifically useful in the context of time series models. So if you're doing things with residuals, you want to see whether the residuals are independent of one another, so they're not correlated over time, a phenomenon that's known as autocorrelation. And the Durbin-Watson will kind of tell you that. The Jarque-Barra statistic kind of looks at, is your data normally distributed or not, because one of the assumptions of linear regression is that your residuals are normally distributed, so you can kind of check that out there. But a lot of this is kind of more ancillary information that you don't usually look at that often unless you're doing a specific case where it's relevant.
Okay, so we're done, right? We can finish.
Yeah, I mean, we gone through the initial data cleaning, the initial exploratory analysis phase, the kind of initial model building and statistical analysis phase, and we got results that point towards our initial hypothesis. We kind of confirmed it a bit, right? We have pretty strong evidence that seems to be true, that critics do rate action movies more harshly than users. But once you do your initial analysis, the next thing you want to do is really get at some robustness checks, right? You want to confirm your analysis, do it in different ways, stress test it to see if the results really hold up. And so that's kind of the last step we'll take you through here.
Awesome. Rock, do you want to sort of point out what our, hypothesis going forward might be?
For example, we want to just look at whether the difference between critic and user ratings will change over time. And we also, for example, want to look at if time, controlling for time.
Right. Yeah.
The round run is it still a significant factor? Influencing the difference.
Yeah. So perhaps people have just made more action movies as we have gotten further into the 21st century because of some reason, which we can hypothesize about, and that maybe that this year thing is a confounding factor. So let's first thing that I always like to do, and this is my favorite part, is visualize. So one thing so we go ahead, we can do this group by year. So this is one way you can do the time series analysis. Another way that you can do it is doing resampling by a year, which we might do a little bit later on, but not today. And let's sort of see what's happening. Let's see. So here, we're looking at RT, user rating, mod, mean, over time.
So we're plotting out the average user rating by year here.
Yeah. Is this expected?
It's interesting.
User rating,
it looks pretty noisy, like very volatile over the early time periods, and then it kind of gives a sharp downturn around the 1980s, and then kind of goes up a little bit after 2000. It's a little bit unexpected, right? You might expect that the average rating for a user over each year would kind of stay constant if the mix of movies are generally independent of a year.
Yeah, or one might expect that they would go down, since perhaps you might expect the quality of movies to be going down over years.
Yeah, given the kinds of movies we see nowadays, that seems possible.
Possible. So for critics, kind of looks the same.
Yeah, it looks the same. Probably even more of a sharp downturn, though, and not as much of a recovery in the recent years, I would say.
Yes. Interesting. So, right, we'd also wanted to check out, see this difference over time. I think it's really interesting. Rock, do you want to?
Yeah, as we can see from the plot, the difference actually changed direction.
Yeah.
Around maybe 70. Actually, no, 80s or even 90s.
Yeah.
That's when I talked about talk from back the future, is because we looked at this plot
yes.
A few days ago, and we know the direction actually flipped.
Yeah, so this provides some evidence, right, that time could be a confounding factor, because here we have the differences literally changing with time, right? And if this has any correlation with more action movies being made recently than movies being made in the past or anything like that, then it's going to affect our results potentially.
Yeah. This was kind of surprising to me, just sort of generally speaking, just as sort of like an innocent viewer, to sort of see that users at one point were harsher than critics, and now critics seem to be harsher than users. But that being said, so I forget who said this, but we decided to. Oh, sorry. One more plot later. So we also looked at is action, and we grouped by year, and then we plot this difference over time, and the difference looks to be very similar. One thing that Rock had pointed out was that, hey, it looks like we didn't even have an action movie before 1960. But the one thing that I just wanted to sort of show here is that if we look at the counts of the data, the counts are extremely small prior to 1997, and after that, we're looking at about 200 movies each year.
Yeah, so the fact that we have such little movies before 1997 probably explains why we have such high volatility in the earlier time series plots for early years, right? Because you're looking at maybe like ratings of 1 to 5 movies, and so if those movies are all deemed very different from one another, then you're going to have this constantly changing average rating over the years.
Yeah. Also, the way we picked genre was contains instead of equal, meaning according to Rotten Tomato, a certain movie can be categorized in multiple genres. And,
right, that's right.
the way we did it is, as long as there is at least one genre that's called action, we'll include it in our analysis.
Yep.
Versus pure, if a movie just is has just one genre that is action, which only I think we have 6 data points, 6 or
here we go.
9
Yeah, exactly.
Yeah, 6 data points.
Yeah.
So that could be a factor to consider as well.
Yeah, it would be interesting to just see what movies those were. the pure action. And we could do that real quick. So I guess I'm actually curious at this. If we go ahead and look at if we're using cleaned, we want to find I guess dot genre equals action, and cleaned. Sort of check what this looks like. Oh wow, Kill Bill. That makes perfect sense.
And lots of Batman movies and Catwoman, which is related to Batman.
Yeah, kind of interesting.
It's funny.
Okay. So one thing that I wanted to do is I wanted to look at this a little bit more closely. Because we have a lot of movies here, I'm wondering if these could be affected by the actual ratings could be affected just by tail events, right? Maybe there's just like the median of movies stays the same year over year, but there's these tail events which are really bad. The problem is that we have a lot of years, so I just wanted to look at the most recent movies. So I went ahead and selected the ones that are 1997 and above. No real reason to do that, and checked out a Boxplot. Again, this is the Boxplot of the differences between critic and users. And yeah, Vinod, you said it just looks like a slight rising trend. So
yeah, so I think when we think back to what we're trying to do here, we're trying to do a robustness check to see if time could be a confounder for genre in terms of the differences between critics and users and average ratings, right?
Mm-hmm.
So here we look at the distribution of differences between critics and users for each year, for each movie release year, and you kind of see that it looks like the differences tend to increase over time for action movies, right? Mm-hmm. And so you could think that before, where we had our regression model that kind of showed that critics and users increases significantly for action versus non-action movies, that difference could have been driven by the fact that the difference seems to also increase with time. So we just want to, repeat the same regression model now, but control for time explicitly and see if that changes the results.
Yeah. Okay. So, I mean, this is basically what we did. So down here, we're doing the exact same regression. We're just adding one more factor in, which is called year. Notice we're not making year a categorical variable. We're keeping it as a numeric variable. And I guess there are some reasons why we're doing this. I know Rock had sort of mentioned at one point that this would lead to an explosion in categorical variables. Right, we'd have a ton of dummy variables. I don't know if you guys want to talk about why we left it as a numeric factor instead of a categorical factor, or we can just go on. We're almost actually to the finish line.
Yeah, so I think given the amount of data we have and the number of years that we're actually looking at, it's probably okay to use a categorical variable. You wouldn't have that many different levels, but the main reason we kept it as a numeric time trend was one, that the trend in the differences over years from the series of Boxplots above looks pretty linear. Like I don't think fitting a line to that trend is a bad assumption, and it just kind of makes the output of the regression model simpler. We'll only have one term for year.
Yeah. Okay. Well, let's just dive in. Okay. Whoa! Looks like year is significant. Oh no! Our regression analysis can't have worked. Just trying to add some suspense, right? Rock, do you want to explain this, or Vinod, whoever wants to jump in?
Vinod, go ahead.
Okay.
Yeah. So if we look at year is significant, right? But then keep in mind what we're trying to do here is a robustness check, so we can take a look at the coefficient on is-action, right? And it's about 0.49. And if you remember to the previous regression model, the coefficient on is-action was around 0.5 something. So it didn't actually change that much from including year, right? And the standard error didn't change, the t-statistic didn't change. So it's still significant and still in similar magnitude. So we can be a little bit more confident that the pattern we're picking up with is-action is a real phenomenon.
A little aside, and this is especially towards, I guess, people doing data science classes. I think a lot of current data science classes focus pretty heavily on prediction, right? And our model is not predictive, right? We're really not explaining much of the variation of the model. It's not predictive, but it does answer the question we sought to ask. I guess this is a little bit different than what you might normally be expected to do in sort of like the capstone project of a data science course. But at least for some of my students that have worked there, this is sort of like very much so in the realm of what they're doing. And it's also, this is very typical data science work, right?
Yeah, I mean, I would say, there's kind of broadly two types of data scientists, right? One, people who work on prediction, machine learning, data products, all that stuff. And the other is maybe what you could call decision science, right? And here is you want to use data science to really understand things, understand the drivers of the business, of the product. You want to understand if something happened, what were the reasons it happened, and really get into why. And this is more on the inferential side of statistics. And this is kind of what we're doing here. We're doing more of the inference style stuff.
So if we're looking to make decisions, if a user goes out there, they see an action movie gets a 6.5 by critics. How good do they expect to feel after watching that action movie? What do you think they would rate that action movie as?
Yeah, I mean, probably like a 7, right? Because about the difference between critics and users, you get about half a rating point boost. So,
well, it's probably 1, given that there's an intercept at about 5
too.
Exactly. Although they're on different scales, so
right.
So I don't know. You should probably divide that by half.
Well, so it's you'll probably like it. Is what we're saying. As one of the last things, this is more just fun. We wanted to check out what are the top differences. Of movies, and these are just all, and then we're going to show you the is actions. So some of the top differences are, I don't know, Big Mama's Like Father Like Son had a massive difference in the critic rating as opposed to the non-critic rating. This makes sense to me. Saw, right? Saw 5. I can imagine there are some people that really like this movie, but critics will resoundingly not like this movie, I imagine. I don't know. I found this fun. Anything else you guys wanted to point out?
Yeah, I mean, I think you can start kind of fitting conceptual reason for why these gaps exist, right? It's probably one group is like movies that critics would love that users wouldn't like, and the other is that movies that critics would think are stupid but users would really like for some reason. Right.
So we also just did this for the actual action movies. There's one interesting idea: Underworld Evolution and Underworld Blood Wars, both action movies, both having very different reviews from critics and users. I don't know. It would be interesting, at least to me, to see the distribution of these reviews, especially because I would imagine some of these things look to me like cult classics. There's a small group of users that all watch these movies and rate these movies.
Yeah.
Right. I don't know. Do you guys have any other? I found this cool, but
yeah, I mean, I think it is exactly what Nate's saying. It's like you got these cult classics that people will just love and defend to the death, whereas overall maybe they're not considered to be the greatest of movies. Always take critics' words with a bit of caution.
Yeah. Okay. So that's going to sort of wrap this up. I'm gonna switch back to our cameras. I'm just gonna ask, like, hey, what did we learn? You know, any little bits to. I hope I'm not presenting to everyone now. Okay. So, anyways, so what did we learn? And I'll just start off. So I'm much more of a tools type person. I love playing with Python. I love getting my hands dirty with data. I don't have as big of a stats background, though it's hopefully not puny. One of the things that I learned, especially you guys didn't see this on screen, but when we were doing the original data analysis, I had done the rookie mistake of not checking the object types of these things. And so I was instead of summing numbers, I was summing strings, and I was getting very weird means and medians, and things looked very weird. So if you guys weren't paying attention too much there, do scroll back and to the point where we actually check the data types of these things and change them, because that can ruin it can really take hours out of your analysis if you just do that consistently at first. It's one thing that I learned. We can just go across the panel. Vinod, you were to my left, so if you want to.
Sure. Yeah. So I'm an inference guy. I'm all about inference and understanding why things are the way they are. And so for me, kind of figuring out that critics do rate action movies harsher than users was interesting. I think one lesson that I took away from this is that you should always keep in mind the goal of your analysis. When we were first doing this notebook and writing out code, we were kind of getting down into pigeonholes, looking at random different plots that were probably pretty orthogonal to our original question.
Yes.
So it's always pretty easy to do that, right? Because there's so many columns, so many variables, so many interesting things you might pick up on. But just always keep in mind your ultimate goal and make sure your plan is working towards that.
Yeah. And to that, one of the things another mistake we sort of made was we didn't collect all the necessary columns.
Oh yeah.
All together. We sort of went in one direction, try to visualize it. We clean it, visualize it. One set of columns, and then figure out, oh, we need another set of columns to be together, and then so it's better to just collect all the necessary columns together. Look at it together, clean it, check data quality issues, and do exploratory work, visualizations. Another interesting takeaway from this study is towards the end, the robustness check, because again, as you might have heard a lot of times, what is it? Regression doesn't tell us causation at all. It's all correlation, and so confounding factors could represent in whatever we're doing. And so we sort of identified time as a potential confounding factor, and when to add time as a regression factor, and again check is action, whether that's still significant. Turns out to be still, but it's interesting just to think through what we've done, review the assumptions we've made, and go from there.
Yeah, I've got to say, Rock was certainly like our drill sergeant, keeping us, because we'd always be like, "Ooh, look at this!" So it's good. You've got to keep your head on your shoulders. Okay, let me just go ahead and wrap up. So I don't want to overly plug, but I hope you guys enjoyed this. If anyone has watched this video and benefited in an interview, if anyone has watched this video and benefited in their day job, if anyone watched this video and helped improve their decision making at all, just in terms of stats and stuff like that, please leave us comments. Please like the video. We want to do more of these, and especially if there's support, we'll continue making them. And if anyone has any interesting data sets or questions,
or would like to do things in R,
or would like to do things in R, I would certainly enjoy that. Less typing for me. Then please, shoot us over. Let us know whether you'd like us to do it in R, whether you would like a particular data set to be done, whether you'd like us to use a particular package somewhere. We're excited to learn new things. Okay, so this is the first one of Data Talks. I hope you guys have all enjoyed it and tune in. We're maybe trying to make one next month. Okay, thanks everybody.
Thank you. Bye-bye.
Take care, guys.